The periodic table is a list of all the atoms in the universe that have different numbers of electrons. Hydrogen has 1 electron. Helium has 2. Carbon has 6. Oxygen 8. Gold has 79. And uranium has 92. Today we know that it is the arrangement of electrons inside each atom that determine the chemical properties. And similar arrangements lead to similar properties. And although each electron in the atom needs 4 quantum numbers to uniquely describe it, we only need to talk about 2 of them in our discussion of the periodic table. The quantum number n determines the gross energy of the electron in each orbital, with some adjustments for the other numbers. And the quantum number L determines the shape of the orbital. All of the elements in the table are arranged into groups based on different values of L. Elements in a given column have their outer electrons in a similarly shaped orbitals. And this means they have similar chemical properties. This is the S group. It has L equals 0, and each row in this group can hold 2 electrons. This is the P group. It has L equals 1, and each row in this group can hold 6 electrons. The L equals 2 group, called the D group, can hold 10 electrons per row. And the L equals 3 group, called the F group, can hold 14 electrons per row. In order to fit the table into a narrower space, the F group is often listed below the rest of the table. But we will put it into its rightful place and just deal with a wide but correct periodic table. Notice I have included helium in the S group next to hydrogen. But I have also duplicated both elements at the right end of the table with the P group. Their chemical properties make both of these alignments useful. In a given group, n increases by 1 for each row in the table. So the outer electrons in the elements, directly below other elements, have more energy and are less tightly bound to the atom. As we add electrons, one after another to atoms, each new electron occupies the lowest available energy state. And so it is the energy levels of the electrons' orbitals that determine where the different L groups fit into the table.